Okay, so the slope of this segment is the rise divided by the run. The rise is, well, take this segment here and turn it around so that you have no, it really isn't higher here than it is here, so I'm gonna make it this way. So here's a point x naught, y naught, 0. Here's the point x naught plus delta x, y naught, 0. So how high is this? This is, not leave myself room to write stuff. And naturally, I follow the pattern of what I just wrote. Instead of writing out what I should, I'm writing out what's correct. Okay. This side is f of x naught, y naught. This side is f of x naught plus delta x, y naught. And what's this? So, you know, the rise is going to be this minus this, right? What's the run? Well, from x naught, y naught, 0 to x naught plus delta x, y naught, 0 is delta x. So the rise is this, and the run is delta x. This simple slope. Okay. Now, what's this expression remind you of?
Limits.
Write it down. Oh. Okay. So the limit, say limits, okay? The limit okay? That's good. Okay. This expression is the average rate of change of f with respect to x between these 2 points. Note that y is constant. Okay? This limit is the instantaneous. At the point x naught, y naught in the xy plane. Now, what is the instantaneous rate of change? What's a word for the instantaneous rate of change of a function? Can you write it down? No, not a slope. It's the slope of a tangent line, but what's the word for the slope of a tangent line? Yeah, derivative, right? And we call this partial derivative. Of f with respect to x. At the point x naught, y naught. Now, these 2 points here lie on a curve in this plane, okay? And here that curve might be represented like so, exaggerating the curvature. As delta x approaches 0, this curvature, the amount of curve, or the curvature stays the same if you define curvature. You know, curvature has pretty much a constant value along here. But this segment becomes straighter and straighter when you look at it. It still has the same curvature, but you're looking at a curve that is in a smaller and smaller window, so it appears straighter and straighter and straighter. Okay? So the slope of this thing, well, the slope of this segment approaches the slope of the tangent line. Okay? Right now, the segment is not parallel to the tangent line. The tangent line is, getting messed up. Tangent line is tangent to the curve. Okay. But as delta x approaches 0, the line segment approaches, the slope of the tangent line approaches the slope of the line segment, or the slope of the line segment approaches the slope of the tangent line. Okay. So we call this a partial derivative with respect to x. What are we going to call this slope, the limit? It's going to be the partial derivative with respect to y. Okay? And you can visualize the partial derivative with respect to x as just slice this paraboloid, or whatever the function is, with a vertical plane parallel to the x-axis through the point x naught, y naught. You've got a curve. And now you're in 2 dimensions, and you're just doing a derivative of the 2-dimensional function in that plane. Okay? And same thing if you slice it in the y direction. Okay, well, there's a notation for that. kind of like the derivative notation. Okay, this is a Greek delta, and it's hard to draw on the board because the board's a little, I think the chalk is a little fun. A better one. I'm going to try to draw a better one. Can't push the chalk easily against this board, but it's like a rounded off D. Kind of like the way the letter rho relates to P. It's like a D without the stem. We'll go on with this. Now this is all the way into the third section. Before you can do a derivative, you've got to look at things like continuity. The function has to be continuous in order to have a derivative, okay? Continuous at the point. And other aspects of functions. And you're going to be putting your understanding of functions and limits and continuity and so forth on a little firmer basis. You're reinforcing what you learned early in your calculus course, okay? So it's a good section, but everything is based on that. And if you keep this picture in mind, it gives you an idea, kind of a looking for a word here. Anyhow, an example of where you're going, okay? Something, losing the word, but you understand what I mean, I think.